Okay, in the last lesson we talked about applications of quadratic equations, focusing on projectile motion problems. Today we are going to continue with more applications and we're going to look at area problems. I will tell you that these are interesting because I don't feel like they're extremely realistic, but they get the practice that you need, so we're going to do some of them. Steps to help you out with these: draw a diagram and label the sides, set up an equation using the formula for area. For a rectangle, sometimes we have triangles in there, you'll see that. Multiply the equation out, so you're going to either distribute, FOIL, whatever, and then solve by factoring or quadratic formula. Make sure it's equal to 0 first, otherwise that does not work. Okay, so let's see what this looks like. The width of a rectangular flower garden is 3 less than its length. Okay, so I have a rectangle here. Let me get a rectangle. Go and draw one on your paper. So always draw a picture first. So I think it's important here. The width is 3 less than its length. Okay. The area of a flower garden is 54 square meters. Find its width and its length. Make sure you find both there. Let's see what we know. Okay. The width is, okay, so here's my width here. There's my length, whatever you want to call it. Let's call this our length. The width is 3 less than its length. Okay. Length, I use the letter L, and I do a cursive L so it doesn't look like a 1. And 3 less than that means I'm going to subtract 3. So my width is 3 less than the length. And then here's my length. Okay. I like to fill my area in here just so I have it. Apologize for the typo there. UA. And then you're going to find the formula, or find the area using the formula. So the area of a rectangle is length times width to get the total area. So that's how I'm going to set it up. Draw your picture, set it equal to the area. Let's solve it. To solve this, I can't do zero product property because I have to have a 0 on that side. So I'm going to distribute. So I get L squared minus 3L equals 54. And I'm going to move that 54 over. So I have L squared minus 3L minus 54 equals 0. Those who choose to use quadratic formula a lot, you can do that. However, I will tell you that we're nice to you, and these typically you could factor. So negative 54 on top and negative 3 on bottom. So two numbers that multiply to give us negative 54 and add up to negative 3 are negative 9 and 6. I can actually go ahead and do x factor here, so I can go right to my parentheses. So I have L minus 9 and L plus 6 equals 0. Then we'll solve. Actually, I'm just going to do this over here so we can see. So L minus 9 equals 0. L plus 6 equals 0. So if I add 9, I get L equals 9. And if I subtract 6, I get L equals negative 6. Now, which one of those can't I use if I'm talking about the length of a rectangle? Well, I can't have a negative side length there. So that means my length has to be 9 meters. And my width has to be 9 minus 3, which gives me 6 meters. So I'm going to do 9 meters by 6 meters for my final answer. Hardest part here is setting this up, so let's do one more. Okay, again, the length of a rectangular flower garden is 3 meters more than. So let's look at our rectangle shape. Rectangular shape. Important information here that we're going to use. Length is 3 more than twice the width. Total area of 27 square meters. We need the dimensions there. Sorry about that. So we're going to go ahead and label this. This is my length here. So this is telling me my length is 3 meters more than, so that's plus 3. Twice its width means 2 times W. So here's my length. My width is just W. And that gives me 27 square meters. So we're going to set this up the same way. We're going to do length times width, and it doesn't matter the order you multiply those. So the length times the width gives me that area, which is 27, and we need to solve. So we're going to go ahead and distribute to get 2W squared plus 3W equals 27. we have to have a 0 there to be able to solve this. So we're going to go ahead and subtract 27 from both sides. So I get 2w squared plus 3w minus 27 equals 0. And we are going to go ahead and do AC split this time because there's a number out front. So 2 times negative 27 is negative 54, ironically the same number that we just had. And the bottom this time is going to be a positive 3. So instead of negative 9 and positive 6, we have negative 6 and positive 9. And this time I can't go right to my factors because I have this 2 out front. I need to do AC split. So I need to write this out, make my 2 groups, and factor my GCFs out. So first group I can take out a 2w, which leaves me with w minus 3. Second group I can take out a 9, which leaves me with w minus 3. And so my factored form is w minus 3 times 2w plus 9. We're going to solve each of those. See which one works. So we're going to go ahead and scroll up a little bit. Set each part equal to 0. So w minus 3 equals 0. And 2w plus 9 equals 0. So if I add 3, I get 3 for a width there. And if I subtract 9, and then divide by 2, I get negative 4.5. Well, I can't have a negative width, so right there, that one's gone. So if my width is 3 meters, that means 2 times 3 is 6, plus 3 equals 9. So we have 9 meters for our length. So we're going to go 9 meters by 3 meters, and we should be good there. So 9 times 3 gives us 27. Okay, that's it for area problems. Like I said, setting it up and labeling the sides is the hardest part. So if you have questions, make sure you ask. This is it for lessons for this unit. So good luck as you practice and get ready for your test. Have a great day.